Good afternoon, this is Schweitzer, and a couple of problems here involving collisions. Working through one main problem now. We have a couple different types of collisions we could have. We could have potentially one object running into another object and simply bouncing off that object. We have another option where an object could bounce into another object and they simply continue on as one new unit. Or we could have a reverse collision where an object simply, that you might say, explodes, where one object, part of it goes one way and part of it goes the other way, which we might have something like that. This example is dealing with this type of scenario and also this type of scenario. We have a person who is going to be firing a gun, and the bullet will travel in this direction, and on a table there will be a block of wood. This bullet will then connect into this block, and then of course the whole block bullet mixture will slide across the table. So we have several questions here that we're going to try and answer. First one is, alright, how fast will the bullet block travel? Okay, so this is a typical collision, completely inelastic collision. In this case, we have the problem number one. We have the momentum initial equals the momentum after final. So the mass times the velocity plus the mass times the velocity of the bullet and of the block will equal the mass of the entire object times the velocity of the entire object. So in this case, the mass of the bullet is 5 grams, or 0.005 kilograms. The velocity of that block is looking like 300 meters per second, plus the mass of the block, which is 10 kilograms, but it has no velocity, so that will eliminate. The entire mass of this thing is going to be 10.005 kilograms. That's the two masses combined, times the velocity, which is what I am looking for. I have velocity 2 there, we'll go velocity final. Mathematically, we are just solving for VF. Alright, so we have this value here is 1.5, which represents the total momentum of that guy, equals 10.005 VF. Divide out the 1.5 divided by 10.005 equals a number less than 1, and the VF equals 0.149 meters per second. So not a whole lot, and that would be somewhat expected because the mass of that block is so much higher than the mass of the bullet. Alright, next question says, how far will the bullet block travel? And I guess I should say bullet. I want to know once they actually connect the bullet block, how far will they travel? So this is a different style problem, older style problem, and we may want to say that the total, use energy to solve this. So the total energy of this thing will have to get converted over to thermal energy in terms of friction. So energy of a moving object is 1/2 mass velocity squared equals mass times gravity times the coefficient of friction times the distance. Verification of those formulas would need to be done earlier in the year, but we want to solve for the distance here. So I'm going to start plugging my values in. 0.5, the mass of the whole thing is 10.005 kilograms. The velocity is 0.149, and then squared equals, well, that we could cancel the mass out of this thing on both sides if you want. Let's go ahead and, well, I'll put it in here for now, but 10.005 times gravity, which is 9.8, times coefficient of friction provided in the problem at 0.2, solving for D. Again, you can just, doesn't matter if it's there or not. The left side is 0.0111 equals 19.6 D. Distance divide out. We have a small distance, which would make sense because it's not traveling horribly fast. And we get the distance in meters is 0.000566 meters, or only about half a centimeter. All right, so traveling quite a small distance. So all right, what else we got here? So we got that guy, we got that guy. How fast will a gun travel and in what direction? All right, so for every action or for every force, there's an equal and opposite force. So as the bullet goes this way, the gun will explode going that way. This is this type of explosion in this case right here. One object goes one way, one object goes the other way, and they don't either of them start with any momentum because it's staying still, but in the end the momentum still equals 0. So the mass of the object, so momentum initial equals momentum final. So the whole mass of the object will equal the velocity of the initial object. All right, now again, it has no velocity, so it doesn't matter there. Final is the mass of the bullet times the velocity of the bullet plus the mass of the gun times the velocity of the gun. In this case, this is going to equal 0 because there is no movement, so no momentum. The mass of the bullet is going to be 0.005 kilograms. And then the velocity of the bullet is 300 plus the mass of the gun. The mass of the gun is given at 5 kilograms. And what's the velocity of the gun? Okay, so at this point, I'm going to add these guys together, or multiply 0.005 times 300 equals 1.5, and of course, algebraically I want to solve for this variable, so I'm going to get this over the other side. Negative 1.5 equals 5, and then the velocity equals, in this case, dividing that out, and we're at about 0.3 meters per second is the velocity. So not a huge velocity either. The last question says, okay, in this sense, how important is to keep a gun firmly and snugly attached to the human? All right, so there are a lot of examples of this. You can see these things on YouTube. But if a gun is just fired, then the mass of the gun is going to be 5 kilograms. But if the gun is firmly attached to the human being, which means it's held in contact with it, then the human weighs, I think I went with 75 kilograms. So now at this point, when we do our math, the reason why is because when this thing is hooked either via a person literally holding it on themselves like a shotgun, or if you're holding a handgun, they'll hold it with your arms locked straight out or pretty tight, that now the total mass rather than 5 grams is 80 kilograms. So my total mass is now increased, which means as the velocity of the bullet goes this way, the momentum of the bullet goes this way, the momentum backwards is much less. Thank you very much. Enjoy the video.